Hello, my name is Joshua Crandall, and I will be working through question 13 on the week 8 pre-lecture assignment. So this one's about escape speed. So first and foremost, it asks what escape speed is. And escape speed is the initial velocity something needs to escape a gravitational pull. So I'm just going to write that down. If I can figure out how to get there we go. So escape speed is the initial Okay, so part B wants you to derive the formula for escape speed, and you're given this formula here, delta K plus delta U is equal to 0. Delta K being our kinetic energy and delta U being our change in potential energy. So we know that delta U is going to equal negative gravitational constant to mass of an object, all divided by the radius of the object. So here, the mass of the object here is the mass of the planet, and then the radius here is the radius of the object. And this little m here is the mass of the object that's trying to leave the gravitational pull. And then we know that delta K is going to equal 1/2 mass times volume, velocity squared. So we can substitute these into our equation. So 1/2 mass times velocity squared minus gravitational constant and P and RP is equal to 0. I'm using MP here and RP here because those are the given variables that they want you to work with, being the mass of the planet, the radius of the planet. And then this velocity here is going to be our escape velocity. That's what we're going to want to solve for right here. So we set these equal to each other. Since it's equal to 0, we can do 1/2 mve squared is equal to our delta U. And then we know that the masses are going to cancel out. We're going to multiply over here by 2. So VE squared is equal to gravitation P RP times 2. And we take the square root of both sides. So we're left with VE is equal to the square root, 2 times the gravitational constant times the mass of the planet all over the radius of the planet. So that is our equation for escape velocity. And then part C, we just want to take all of the values that were given and substitute it into this equation. So our values are mass of the Earth is equal to 5.98 times 10 to the 24th kilograms. Radius is equal to 6,380 kilometers. And then G is equal to 6.67 times 10 to the negative 11 Newton meters squared, kilograms per second. Okay, so we're just going to substitute all of these variables into our equation. So we get 2 times 6.67 times 10 to the negative 11th Newton meters squared. All times MP, which is 5.98 times 10 to the 24th kilograms, all over RE, which is 6,380 kilometers. And we're going to want to change that to meters. So that is going to be 6.38 times 10 to the 6th meters Okay, and then we're just gonna put that into our calculator, which I've already done to speed things up. So that comes out to 1181.966 meters per second. We have 3 sig figs, so it's going to come out to 11,200 meters per second, or 1.12 times 10 to the 4 meters per second. There we go. And there is our escape velocity to escape the Earth's gravitational pull.